Hi, this is a presentation for the paper Find the Bot, Gamifying Facial Emotion Recognition for both Human Training and Machine Learning Data Collection. In daily social life, facial emotion recognition plays a crucial role for human-human interactions. In the psychology field, extensive research has shown that higher FER is associated with various psychosocial benefits, including better relationship quality, social functioning, and eventually improving academic and workplace performance. Even recently, FER has also played a crucial role in human-machine interactions. With the rise of effective computing applications, the use of automatic FER machines has become commonplace in many contexts, including security, driver safety, the healthcare system, and even the hiring process. Although the importance of FER is increasingly emphasized, accurately recognizing others' facial emotions remains challenging for both humans and machines due to its subjectivity, ambiguity, and diversity, especially in faces encountered in the wild. Therefore, there has been extensive work to improve their FER skills. With the advancement in software technology and the exponential increase in online interaction, various computer-based training tools have been introduced. For human FER training, computer-based training tools serve as a scalable and flexible alternative to conventional in-person training programs. However, we identified 4 challenges in current human FER training interfaces. First, these tools typically employ a sign-based approach in which facial expressions are divided into small action units, such as cheek raisers and lip corner blur. This sign-based training makes it hard to capture the diversity and ambiguity of facial expressions found in the real world. Second, researchers have identified that self-administered training on a computer is less effective than administered by a human instructor or in small groups. Third, many tools include only a fraction of the 3 essential sessions, namely instruction, practice, and feedback, which is less effective than a combination of all 3. Finally, this simple task design demotivates learners from consistent and effective training. Meanwhile, for improving machine FER performance, researchers have made promising progress in building diverse training datasets with in-the-wild images. Despite these efforts, most existing datasets still do not capture the diverse interpretations of facial expressions. This is because existing FER data collection interfaces have limitations as follows. First, the images are typically annotated by only 1 or 2 annotators assigned per image, thereby resulting in biases and erroneous decisions. Second, single-choice interface design make it difficult to annotate facial expressions that are complex and ambiguous. Third, researchers have recently focused on constructing large-scale datasets with judgment-based labels, as this approach is more effective than a sign-based one for capturing emotional social norms shared by a large population. It requires the collection of a large number of judgments to aggregate them into answer distribution, but crowdsourcing a reliable distribution incurs high expenses. Finally, simple task design demotivates annotators, resulting in careless and poor label quality. To address these challenges within a single application, in this work, we aim to design an interactive and collaborative web-based game that effectively engages the general population to support not only human FER learning, but also the collection of rich and reliable judgment-based labels. To this end, we set 3 specific design goals by reflecting feedback from 3 rounds of prototyping. First, we want to enable diverse layers of interactions to support socially agreed upon interpretations of emotions. Thus, we designed the game to engage players in observing and providing feedback to each other. Second, we want to minimize the difficult and effort required for the labeling actions during the game. Thus, we brought complex labeling actions into small unit of work, that is binary labeling. Finally, we want to provide game rules and elements that are easy to learn. Therefore, we use mainstream game plot. With three design goals in mind, Find the Book seamlessly incorporates a wide range of suggestions and guidelines from gamification, education, and crowdsourcing to motivate players. More details of each strategy can be found in the paper. Here's the overview of gameplay. Find the Book is inspired by the globally popular game of Mafia and involves 4 human players who are anonymized in the game, along with an AI bot pretending to be a human. The game goal is collaboratively finding the bot among players. If 2 human players are deactivated or fail to find the bot, they lose. Otherwise, they can win the game. The game consists of 4 rounds, each featuring a randomly chosen emotion keyword from basic emotions. In each round, 6 game stages unfold. The 6 game stages are based on the rules of the Mafia game. We walk through a scenario with Daya, who is playing the game in her free time. At the start of each round, a randomly set emotion keyword is shown to all players. In the labeling stage, each player is assigned 4 different facial expression images and has to click all the images that correctly match the set emotion keyword. After the labeling stage, players move on to the scheming stage, where they can quickly review the generated image label sets of all players. In the pointing out stage, every player except the bot takes turns to point out a player they believe might be the bot due to suspicious labeling. Subsequently, all players participate in the voting stage to conclude whether the pointed player is really a bot or not by evaluating the label's plausibility. If the majority disagrees with the suspicion, the next player takes his turn, and the pointing out stage is repeated. If all labels seem plausible, players can click the pass button to skip pointing out someone. If the majority agree with the suspicion that the pointed player is a bot, he enters the last defense stage. During this stage, the pointed player has to identify one of the label images that may appear unconvincing to the other players. If the player fails to find it, he will be deactivated from the game. To help understand the image with controversial labels, during the advice stage, all players can view a graph showing the distribution of labels for that image. As a deactivation penalty, the deactivated player watches other players' gameplay until the game ends. Within the 4 game rounds, if the human players successfully find the bot, they win. When human players win, they earn rewards, the amount of which depends on how quickly they find the bot. After finishing the game, all players are returned to the main page, which displays their profile and the leaderboard. Before conducting user study, we collected ground truth measures from 275 people by online survey. For this, we utilized one of the most widely used measures of FER, scoring on a scale from 0 to 64. The ground truth measure served 2 purposes. First, to establish criteria, that is first quartile 40 score, for dividing participants into a low FER group or not, And second, to provide a basis for judgment-based scoring. To evaluate the feasibility of Find a Bot, we conducted a user study with 59 participants. Based on the first quality score of 40 on ground truth measures, we classified 22 participants into the low FER group and then randomly divided them into learner and control groups. The study consisted of two different tasks. Both the learner and ordinary player groups were assigned the task for playing Find a Bot. This task was conducted over 2 days, with each session lasting 90 minutes. In these sessions, participants take a pre-test to evaluate their FER scores before playing the game with a pre-matched team consisting of 1 learner and 3 other players. Afterwards, they take a post-test to assess improvement in their FER scores and complete a survey on user experience. To compare the effectiveness of Find a Bot with current interfaces, a control experiment was conducted. The control group was assigned a plain labeling task. During the session, participants take a pre-test and label 200 in the wild facial expression images, mirroring the approach used in current data collection interfaces. To provide a consistent experience with the learner group, we used the same set and number of images as those used in the game. Afterwards, the control group take a post-test to evaluate improvements in their FER scores. The analysis of game log data reveals a highly concentrated game interaction and a progression in emotional assumptions. Additionally, the result of the post-survey showed that the game was highly motivating and engaging for participants. The comparison of inter-rate reliability and the trend of pre- and post-test responses indicates an improvement in judgment-based FER scores within the learner group. The analysis of the Gini coefficient of collected labels and pre- and post-test shows an increase in the social agreement of collected labels. We have 3 main takeaways from the study. First of all, we suggest 4 task properties to generalize our approach to other domains. Second, we identified 2 important considerations for designing game interfaces that successfully engage and motivate participants: the benefits of a consistent and attractive UI design, and the usefulness of incorporating elements from mainstream games. Finally, we identified the specific cases where annotations were distributed across multiple categories. To address this issue, we suggest adopting multi-label learning approaches as discussed in previous work. In conclusion, we investigated and summarized the primary limitation in the design of both existing human FER training and machine learning dataset collection interfaces. We proposed Find a Bot, a web-based game that adopts findings from literature in gamification, education, and crowdsourcing to improve the performance of human FER training and FER dataset collection. We show evidence that Find a Bot facilitates consensus on emotional perceptions through active interactions, benefiting both learning of emotional social norms and the quality of collected labels. We provide generalizable insights and recommendations for designing, engaging, and motivating games with a purpose. Thank you.